Good evening. This is an example of a border problem from Chapter 5b on factoring. The numbers here represent the dimensions of the picture. One of the classic border problems is that we have a picture that, if I draw the picture, has a width of 25 feet. These would probably go inches because that's more like a picture. And 40 inches. Then we take that picture and we add a border to it. So whereas the original one had 25 inches by 40 inches, we're now adding a border on all sides. And this border is of unknown width. So we say let x equal the width of the border in inches. Now here's the key to the border problems. When we add a border to all sides, we basically add two border widths to the width of the entire picture. This is confusing because we're saying the word width to mean two different things, but we're basically adding two borders or two border widths to the width of the picture. So let's picture this picture with like a scene in it. We have a person standing in the middle of the field and there's a tree and something. And on this border, we've added x to the width on both sides. Looking at the width of the new picture with the border, we have the original 25, but we're adding x twice. And so the new width is now 25 plus 2x. We can call that the new width of the frame, since that's basically the width of the frame. By the same logic, our length is now the original 40 plus x, or 40 plus 2x. And that's equal to the new length of the frame. Well, we need a little bit more information to solve this problem, and it turns out that in the problem we would be given something like the fact that the area of the frame is equal to 504 inches squared. This is now a little bit more of a complicated problem because we know what the total area of the entire thing would be. I know that the total area would be equal to the new width times the new length. Or if I labeled this figure again, it would be equal to 25 plus 2x times 40 plus 2x. So 25 plus 2x times 40 plus 2x. Now, the area of the frame is just the area of the highlighted region here. So we have to figure out the total area is the area of the frame plus the area of the picture. Well, if the area of the frame is 504, the area of the picture would be the 25 inches times the 40 inches. Now we have an equation. We're going to have to simplify this equation, but at least we have an equation to work with. I'm going to take the two binomials on the left side and FOIL those. So 4 times 25 is 100, times 10 would give us 1,000, that's the first. Outer, 25 times 2x is 50x, inner is 80x, and the last is 4x squared. Then we have 504 plus 1,000. Well, my 1,000s can cancel, because if we subtract 1,000 from both sides, we get 0 for that part. And if I move everything to the left side, I get 4x squared plus 130x minus 504 is equal to 0. My goal now is to set everything equal to 0 and to factor out a greatest common factor. Well, I can divide out 2 from both sides, so if I divide both sides by a 2, I get 2x squared plus 65x minus 252 is equal to 0. I can't take anything out, so I can try to factor this. I know I'm going to have a 2x and an x. I know I'm going to have a plus minus somewhere. So I have to factor out 252 to figure out what's going to happen here. Well, 252 can be 126 into 126 can factor further into 43, correction, 63 into, and 63 is made up of 7 and 9 and 2, bring down this 2. It turns out through some miracles of factoring that if I take 252 and I pull it and make it 126 and 2, and make that 63, and make the 63 be 7 and 9, and 2, then what I have is 7 times 36. And if I do 2x minus 7 and x plus 36, that gives me what I need. Foil it back out and I get 72 minus 7 or 65. Well, this would be x is equal to negative 36, and that can't be true. But this is x is equal to 7 halves, and x equals to 7 halves is x equals 3.5. That has to be true. That's 3.5 inches, and that helps me figure out, okay, so the border of the width, or the width of the border, I should say, is 3.5 inches. So the width of the border is 3.5 inches. Does my answer make sense? Let's go back up to the problem. Adding 3.5 inches to all sides means that basically I'm adding 7 to the width and I'm adding 7 to the length, making my new width 32 and my new length 47. Multiply those out and I should get 1,504, which would be the 1,000 right here plus the 504. So that works.